Warning, your RAG system might have a serious issue. This is a quirk that a lot of people don't know, but your RAG system right now might be degrading in performance by 5, 10, maybe even more percent without you doing anything. Literally behind the scenes, as it's running, it might be getting worse over time. This is something not a lot of people talk about. We're going to be talking about it today in this episode of RAG Masters.
Hello and welcome to another edition of RAG Masters. Yes, a show about, you guessed it, retrieval augmented generation. Maybe the only show in the world about retrieval augmented generation. We stand alone, but I stand together. Here with Daniel Warfield, I'm Katz, your host, a 20-year tech entrepreneur. But I stand here together with Daniel Warfield. Welcome, Daniel.
Hello,
RAG
hello.
engineer, data scientist, and a real expert on retrieval augmented generation. And we've got a big show today, a big topic that I think a lot of people don't really know about or fully understand yet. When you try to scale a RAG system, especially a vector-based RAG system, which they almost all are, you might have trouble waiting for you that you don't really know about yet. And so we're going to get into why vector systems or why RAG search can start to fail at scale and what you can do about it. There are solutions, there's a different approach. We're going to talk about that too. So with that, Daniel, why don't you walk us into, you've got some slides, walk us into the problem, and then we'll get to the solution.
Yeah. All right. So I got slides, and we're going to be talking this whole conversation pretty much about, drumroll please, bada-bada-bada-bada-bum. The slides will come. We're very excited about them.
Slides are on the way. So, slide.
So we have this graph. And what you can see in this graph is we've tested different RAG systems. We'll get to which RAG system we tested. And we tested those RAG systems basically across a range of erroneous pages. So we ask them basically the same questions, but we give them different amounts of distracting documents that are not relevant to the questions. And as you can see, all of them experience a degradation in performance. And we'll get into the specifics, but the punchline really is as you add documents to your RAG system, it will get less accurate, which is kind of antithetical to the common wisdom of you put more data into any AI system, it gets better. In some ways,
what people think more data, better, smarter, just don't take the dump truck and just back it up and throw as much as you got into it, and like brilliant things will come. But there's a trend that you might need to consider when you're doing something like that. So there's some natural questions, and we're going to talk about them. So why does RAG get less accurate? Like, what is the mechanism? And we have different RAG systems that we're testing here, and they get worse in different amounts. Why do they get worse in different amounts? What's the difference between them? And also, what do I mean by less accurate, right? Like, let's get kind of into the specifics here. Like, what am I really talking about? So I want to start with this question of what do I mean by less accurate? So we can kind of understand what we're talking about. Okay.
So we did a test. Neil knows this very well. This was a big test we've done. It's a lot of work to test these systems. We did it for you guys. We took 310 pages.
Yep. 310 pages. Go ahead.
Yeah, we took 310 pages and we constructed 92 questions around these documents, right? So these are questions like, hey, what is this information? What is that information? Can you give me the branch rate in Belgium? What is the definition of a telco? Like a bunch of questions about these documents. And here's some examples, right? So what is the corporate tax rate in the United States? And within one page of one document and one table, you can see that the national rate in the United States is 21%. We have other questions like, what are the diminishing forces of systemic risk? Sorry. And you have to kind of observe this diagram. And if you look at this diagram, you can see kind of on the bottom, there's a bunch of diminishing forces that it lists. We also have like maybe more specific questions like on tax page 46, what is choice A, right? So an ability for a document to really understand everything about a document, not just general purpose stuff, but really specific stuff like, hey, can you look up what's on page 46? We asked a bunch of questions about these 310 pages of documents. And then what we did was we got a bunch of other documents that are not these documents. And we basically padded this data set with this irrelevant information that is not relevant to the questions being asked. And we constructed more and more difficult documents with a higher noise to signal ratio, right? So as you add more of these erroneous documents, in theory, the amount of useful information in the entire data set becomes less potent. Like that's kind of the idea.
Yeah, and this is really relevant in the real world of building RAG, where it's nice when you do a test and you've got 100 pages and you've got 100 questions, and your data set's it's right there. But in the real world, when you do RAG, people will load up hundreds of thousands or maybe millions of pages of content because people may ask thousands or millions of different types of questions. You need a large data set, typically to encompass a division of a hospital or encompass a giant lawsuit or whatever it is. So lots and lots of documents, and for any particular question, most of those documents don't matter.
Exactly.
And that's what we're setting up here, I think, which is smart. I like how you set this up.
Yeah, thank you. I appreciate it. And this is kind of an important distinction, and I think it's cool that we're getting to this early, which is like if you add a bunch of more documents, your RAG system might be more capable generally. It might be able to answer more questions. What we're saying is given a specific question, the more documents you add, the more likely maybe, and as we will discuss, if this is true, as you add more documents, your likelihood of answering a specific question correctly tends to decrease. You might get generally more performant across a wide range of questions, but your specific capabilities will start to degrade. And that's what we mean by saying that your accuracy will degrade as documents are added.
Any particular question, your accuracy can start to go down. And that's a big deal for enterprise RAG. And I don't think a lot of people are talking about it yet because a lot of systems haven't gotten scaled up yet. A lot of companies are in POC mode, or they're experimenting. They're trying to figure out what their play is, and they're doing RAG on a small scale. But I think we all know for this to become deployed in financial systems, healthcare systems, government, etc., it has to scale or it's not really going to work. And so I'm glad we're bringing up some of the accuracy issues that people haven't really faced yet, I don't think, but they're about to potentially run into this roadblock.
Absolutely. It's kind of I think it's an oncoming existential issue. We'll see if it plays out. For us, it's a really big deal.
Yes.
So we have this degradation in performance across these systems. But a natural question might be, why does RAG get less accurate? And we kind of covered it, but I think we can kind of dig in a little more. So, you have a question, what color is the sky? And then you might have a document that says the sky on Earth is blue, right? And then you might have another document that you add from like your sort of space data that says the normal hue of the sky during daytime can vary from pinkish red to yellow brown butterscotch color, which is totally accurate on Mars, right? And devoid of context, your RAG system might think that what color is the sky? This one says it's brown. Is this even a wrong answer? That's kind of a theoretical question because you didn't really clarify what you mean by sky. But the perception from the human is that this is an inaccurate answer because humans, when they say the sky, they mean the Earth sky generally, unless they, clarify. So this issue of accuracy, we're really tackling it from the human's perspective of, is this, correct or not? Like, is this a good answer that I would expect if I asked another human that could access this data? It's interesting. This choice of metric, is it technically in the documents or is it the answer to the question that we want? This is kind of, you kind of have to make that distinction yourself as a researcher. We think generally that, within reason, if you have a well-qualified document or a question that's specific enough, usually, this would be considered a wrong answer.
Sure.
Like what color is the sky on Earth? This would be clearly wrong. So there's a little bit of how do I say this? There's a little bit of a responsibility on the question asker. This question's maybe a little too broad. But yeah, this question of what is accurate on a question by question basis can actually be kind of difficult to answer.
Okay.
But it's kind of interesting. This one is a little more clear cut. which is like if you ask, hey, what color is the sky? And then you have a retrieval system that, you have a new document that says No Man's Sky is an action adventure survival game. Your RAG system might be confused about this particular document, and it might retrieve this other document that mentions the word sky. Maybe for some reason, like color, the way color interacts with the search query makes the second document more likely to be retrieved than the first document. In this specific example, when you're dealing with large amounts of documents and large amounts of questions, the quirks of these systems can come up. And this is also a very common failure mode, which is completely wrong, which is that the retrieval system, when exposed to large amounts of documents, it might retrieve something that kind of tricks the search system into thinking, hey, this section of a document is relevant to the question, but then the language model looks at it and goes, this isn't relevant to the question. And then that's when you get this document, no document answers this question, no context answers this question, because the retrieval system retrieves something that wasn't relevant when it could have retrieved something else that was relevant.
Yeah, that makes sense. If it packs too many of these in there, I mean, if you
this becomes more and more likely of a problem. The more and more things you add, the more and more ways you can trick your search system, the more and more likely it is for it to start retrieving these erroneous sort of excerpts.
Yeah, that makes sense.
So, in my opinion, and in my experience, this is still very much an open question. Like, this is an active point of literature. I don't think there's this like the definitive claim show, at least right now. But in my opinion, based on this test,
sort of maybe right claim show. That's what you're going for.
We're trying our best and we're doing good science show because this is cutting edge stuff. This is cutting edge stuff, right? So but based on, we did this 92 questions across a large amount of documents across these different sort of partitions with this erroneous data, and across a lot of them, in my experience, as combing through these, hours and hours and hours, those are really the two classic failure modes.
Okay, so do we have examples of this, maybe to show of things going south?
Yes, we do. So, let's see. Oh yeah, here they are. So we asked a question, what is the branch rate in Belgium? And, when exposed to the partition that had 1,000 pages and 10,000 pages, Llama Index.
This was Llama Index and Pinecone together. This was just Llama Index using its own vector database.
It actually, it doesn't really matter from a...
You can run it twice, actually. You can run it with Llama Index with its own vector and then Llama Index with a Pinecone.
Yeah, I don't think that the vector search system has a big impact on performance. It's possible that when you're doing cosine similarity search, there are some tricks that some systems use to make it faster by approximating cosine similarity rather than doing it perfectly accurately. But generally speaking, it seems like it's the quality of the space itself rather than where it's being stored. And across all of our tests with Llama Index and LangChain, we were using text embed, Ada, whatever, the classic OpenAI embedding model for turning text into vectors for a RAG system. So I don't think it matters exactly where the vectors are being stored as long as they're being searched with cosine similarity. But I think you're right. I think it was
what we're showing.
Yeah, gotcha. But yeah, so we had 1,000 pages and 10,000 pages. And we asked, what is the branch rate in Zimbabwe? And there's this table that has branch rates for a bunch of countries for, I think, regional banks. And that's kind of the context that we're kind of working in.
Yep.
And for the 1,000 and 10,000 page data set, it was answered correctly, which is 24%. But then for the 50K and 100K data set, it says the withholding tax, WHT rate, on payments made in respect to head office charges for a branch in Zimbabwe is 15%. So I don't know where this came from, but it seems like
table that had other kinds of branch rate information that it got confused with, it seems.
Yeah, exactly. And you might, it's kind of philosophical. Is this wrong? Right. But it's like the context of the question is, what is the branch rate in Zimbabwe? Versus there is a branch in Zimbabwe. it kind of, I guess, depends on the context. Maybe you could change the query, but what we found is that like it doesn't get like better, right? Like it always gets more confusing and it always gets a little worse. So, it's kind of interesting. I want to go into another example.
Yeah, let's rapid fire through some of these.
Yeah. So for LangChain, what are three typical stages of postmortem activity? There was this table where, like, when you're planning someone's, or it was actually a page of a document with some complex textual formatting, and it was talking about if someone dies, how do you deal with their estate? What steps do you undergo to plan for that? And for 1,000, 10,000, 50,000 pages, it had a really great answer. It listed out, it's cut off here, but it listed out all of the steps and like kind of what happens. And then at 100,000 pages, it says the provided context does not specify the three typical stages of postmortem activity. So it's straight up
to get dumber as it should have gotten smarter. It appeared to get dumber, essentially.
exactly on this question, right? Like if you asked it other questions that were relevant to these erroneous documents, then it might have done better. But on this question, by adding this additional information, the RAG system essentially forgot the answer to this question.
Yeah, it couldn't sort out it essentially couldn't sort out the right answer during the search process. But you'll get into that in a second, I think.
Yeah. And then this one was kind of interesting. I saw almost exclusively that things get worse, but there is a little stochasticity to this, depending on the system that you're working with. So GroundX, our system, it actually got this question right on 1,000 pages and 100,000 pages, but it got it slightly wrong on 10,000 pages and 50,000 pages. And this is kind of interesting. On 1,000 pages and on 1,000 and 100,000 pages, it got basically all of the information that we deemed to be the correct answer correct. And then on 10,000 and 50,000 pages, it only provided the sort of like a subsection of what we deemed to be the correct answer for this question. So as you inject additional information and a system ranks stuff, the context that you provided the language model changes. So even if you still have like the right answer, you might have different information in the context that prompts the language model to interpret it slightly differently, which can cause stochasticity in the output, which can cause a little bit of variability.
Fair enough. And how great are these accuracy? I saw you had a chart there. How big are these accuracy losses once you start to scale up?
Let's see. So well, actually,
different with the numbers on it right there.
Yeah. So we found that with GroundX, our system, we experienced a 2% degradation in performance, while LangChain and Llama Index experienced a 10% degradation and a 12% degradation, I think, respectively. LangChain 10, Llama Index 12. And that was across 100,000 pages. And is this exactly linear? There's not really quite enough data to tell, but it appears to be quasi-linear in nature.
Right. If you go out to a million, it's not totally clear what happens yet. But I do want to make one distinction. Tell me if I'm wrong here, that we're saying LangChain and Llama Index, but we believe the real issue here isn't the orchestrator, which is what those two brands are. It's using vectors to store your information and cosine similarity to search it, which both those systems are doing, but it's really the reliance on a vector strategy and a cosine similarity search strategy. Not so much that LangChain or Llama Index are doing anything wrong here as an orchestrator, but the underlying technology that most people have chosen to store their data, being vectors, has this kind of liability in it as you scale. Is that a correct summation of the situation?
That is my thinking, and that's our thinking. We have a data scientist behind the scenes. He was on one of our episodes, Ben. We've talked about these results a lot, and we've kind of conferred and did a little bit of research. And we think the culprit, as you perfectly said, is vector embeddings. LangChain and Llama Index, they both use vector embeddings. We use this sort of semantic search, kind of older school textual search system, which has some different characteristics. So now I want to try to answer the question, why do different RAG approaches experience different degrees of performance degradation? So we kind of have an idea of generally why it happens, but let's kind of get into some of the specifics. And now we get to the point where it's a lot of theory, right? Like I don't think as a industry we know why this phenomenon exists, but this is kind of our understanding. So we have these two competing approaches. One, you take all of your text, so you take your document, you chunk it, whatever, and you turn it into vectors using something called, an embedder, right? An
Yep.
encoder. This is an AI model that's designed to organize text essentially. And it's designed to organize text for retrieving information, for searching information, for comparing information. It's designed on a large amount of text to organize text. And the way it organizes text is it basically takes a block of text and it gives it a tag. That tag is a list of numbers, which can then be plotted in a high dimensional vector space, which can be thought of as like a bunch of dots. So when you're doing vector embedding style retrieval, what you do is you take all of your documents and you put them in the space. And then you take your question and you put it through the same encoder. And then
Yep.
you use that tag to put your question in the space. And then the relevant documents or the relevant sections of documents to your question are the dots that are close in proximity to your question dot. And that's how it searches. And it uses some fancy stuff called cosine searching. It doesn't actually use distance, but like that's the general vibe.
Yep.
With textual search, you do kind of some more, maybe one might say naive things, right? You might apply, and this is the text versus encoding or versus embedding. You might apply filters to the data to get rid of things like the, and, but, or whatever. You might use these things called n-grams to break or connect data together or words together to create chunks of meaning that you can then compare against. You might have phrases that you query against. You might have some ranges that you can kind of compare against. You might boost certain terms. You might sort of break things up. Like all this like kind of classic algorithmic text search stuff that was kind of before the AI era, right? So you have these two competing sort of approaches. The issue with embeddings, one, they're really freaking cool, right? LLMs use embeddings under the hood, right? Like they're a really kind of natural approach because LLMs use these complex high dimensional vectors. Why don't we use these for search? And I'm not going to say that they're wrong because they're not wrong. They're an approach which has a lot of really interesting and exciting sort of applications. But one of the problems is it's a big honkin' AI model that no one really understands under the hood. Like it's impossible to say this is exactly why this is here and that's there. So then when you start adding a bunch of data in and the model is just kind of organizing stuff however it organizes stuff, you might get to a certain point where it's like, is this really the best organization for a RAG context specifically versus a ranking versus a re-ranking context? Is this like perfect for my approach? Maybe I want to tweak it a little bit. And you really can't. Like you just have to kind of deal with whatever vectors this thing outputs.
There's no observability inside a vector space, essentially. I mean, you've turned your words, which you could understand, into very large arrays of numbers, which you can't naturally understand. So what's in it and how did it get vectorized that way? You just have to trust the smart people at some smart companies are doing a good job for you.
Yeah, and that
state of the industry today.
That problem is exacerbated because a lot of people are using OpenAI embeddings and they don't really expose how their encoders are trained, right? So they have a bunch of metrics, and those metrics are very impressive, by the way. Like, right? They can.
They do sound very good.
And they're the encoders that OpenAI puts out are really good, and they're kind of the ones that kind of I think they wrote the clip paper. They're kind of like the encoding people.
Can I tell you a not well-known secret about OpenAI?
Yeah.
Actually, specifically to this. So, once upon a time, we've been working with OpenAI a long time. We've been using their technology before they had ChatGPT, before like the whole craze got going. And in the early days, that we were like one of the first 100 developers working on the technology, and they used to ask our advice. They don't ask us anymore. They're doing just fine now without us. But they had a RAG system. Actually, most people don't realize this. They had RAG. And they didn't vectorize the data for RAG. They actually kept it as text, and they were using Lucene, which kind of version of an open search. People may be familiar with that term. They had a different approach. Then they decided, that when they launched ChatGPT, it became a giant monster hit. For whatever business reason, they decided to shut off this RAG component to what they were offering people. I mean, we think that's good. We're in the RAG business, so we're happy that we get to do that, and others do too. But they also just erased all the documentation about it, which was interesting. And from that point forward, they were telling everybody, you need to vectorize, you need to embed your data. Now, I don't want to be conspiratorial with a thin hat, but I will say that telling the entire industry that they need to vectorize their data to make this work means that you have to pay OpenAI or someone like them to vectorize your data to make RAG work. Is that why they decided to get out of the RAG business? I don't know. Is that why they decided to say that you have to vectorize instead of these other approaches that they originally had actually promoted themselves? I don't know. But that's the state we're in. Not a lot of people know the history. When we started getting involved in this process before RAG was technically RAG, it didn't have a name, the white paper wasn't out. We kind of were following in and agreeing with their philosophy about how to do this. And then the world changed and everyone forgot the history. So a little tinfoil hat sidebar for you.
I love how ancient history in software is like 5 years. It's like,
I don't think it's 5 years. I think it's 36 months or something.
Wow, that's so funny. You're like an archaeologist.
Yeah, that's right. ChatGPT came out like literally 2 years ago, right? It was like a November.
Was it really?
Was it 2 or 3 now? It came out, I think, in October, November. I mean, it wasn't long ago. Obviously, it's changed the entire world, and we're happy for that. And it's really amazing. But strangely enough, they did have a different approach to RAG before they changed the world. So just a thought for those out there who think it has to be vectors. Even the creators of this industry weren't doing it that way.
Take the tinfoil hat on, take it off, hang it up. That's up. I
wish I had it with me. It's in the closet. I usually wear it during the day, but
so yeah. So there's some modern research around this idea, right? Like, and we got slides for it. So are these old school text search strategies competitive? And there's a lot of like kind of emerging research and companies kind of experimenting with this idea that are saying that, you know what, these old school text search strategies are really not that bad. Actually, they're competitive a lot of the time with embedding, and you can actually see what's going on and you can adjust them based on, the specific thing you're working on significantly more easily. And
potentially don't have some of these scale problems of the similarity type search, essentially.
Exactly. And so I think, so it still is a problem, right? No matter how good your search strategy is, there's always going to be some collision. Like, you might have a question, what color is the sky? And one might just say the sky is blue. One might literally say the sky is red. There's really not a great way to get around that. You just kind of have to deal with situations like that. But sure, you can see clearly from this massive difference in performance degradation that some systems, get stuck with, the realistic things that are going on, and some systems degrade significantly. And I think it's telling that both of the ones that degraded significantly in this test were both vector search based in the way they conduct RAG.
Yep. Fair point.
So,
what's the conclusion here?
Yeah. So why does RAG get less accurate? It gets less accurate because the space of things that can be searched, you can have collisions in that space, right? So you might try to search for something and there's something that has information, but you might accidentally retrieve something that does not have that information. And what I mean by less accurate in this sort of environment is, for a specific question, your ability to answer that question effectively will tend to degrade as you add more documents. You might be more capable generally, but for specific questions, your performance will likely degrade in accuracy. And the reason we think there's a disparity between this solution and that solution, chiefly right now, is the approach of retrieval. And it seems like when you compare a well-constructed vector search with a well-constructed text search style system, text search is significantly more robust against this phenomenon.
I like this conclusion. Clearly, this is how we do things. It's what we have found to be true. And by the way, our experience at iLevel, and this is not, I'm not saying this is a promotion of the company. I'm saying it just from doing it a while. It's not like we didn't try vectors. It's not like we thought this is a terrible idea. When OpenAI said, "Hey, you need to vectorize your data," that's going to be the approach. We said, "Great, let's go do it." And we did it, and it didn't improve anything. And then it became hard to observe, and then it became hard to manipulate. It became, wait a second, I've got this I can't control the structure of my database anymore because it's all being vectorized and sits as an array of numbers. I don't have much control. And you see people now trying to deal with that problem by adding other databases onto their database. So now people are adding graph databases onto a vector database. Now, why are you doing that? Well, all of a sudden the vector database doesn't do certain things. I need a different database to try to create, relationships between concepts that vectorization is not doing. So it was really like we found when you got in the weeds with the vectors, as you said in the beginning, like vectors aren't a bad thing necessarily. They can be great. But when you got in the weeds of building complex scaled systems, RAG systems on them, you had the scale problem, you have the observability problem, and you really had this like lack of control. You couldn't really control the data structure you wanted in your application. And that for us became really important because we were building what we call semantic objects. You didn't really get into this in the explanations, but it's the chunks in our universe. Yeah, it's a chunk of text, but it has a lot of metadata around it, which explains where it comes from in the document and where it comes from in a page of a document. It has other generations around it, which you can then do a weighted search on, which gives you, again, a lot of control over how that search works, which with vectors you don't really have. So anyway, that's my 2 cents on the history of how we got here.
I think I did miss that. I'd like to double down before we close. I think that's a great point. Just because you're doing old school text search doesn't mean you can't be using fancy AI to make the text that you're doing old school text search against, right? So the barn doors are opening in terms of approaches. And this idea of just use the hottest thing. Now we have a bunch of tools in the tool shed, and it's time to really play around with the old ones and the new ones to use the right tool for the job.
Preach. Amen, brother. Thanks for taking
right.
it to Vector Church. I appreciate it. And with that, thank you, Daniel Warfield. And thank you, everybody, for joining us for another episode of RAG Masters. Of course, like and subscribe. I'm supposed to say that at the top. I always say it at 30 minutes in. That's the wrong place to do it. But please do so anyway if you're still watching with us. And we'll see you next time.